So in the last session, so we covered how we can implement customized sorting by comparator. Are you able to understand? So comparable meant for what? Comparable meant for what? Default natural sorting order. Comparator meant for what? Customized sorting order. We covered already this point, right? Okay, this is. Now the next example, I want to insert string objects into the tree set. My target is I want to insert string objects into the tree set where the sorting order is reverse of alphabetical order. Default natural sorting order is what? Alphabetical order, but my required sorting is reverse of alphabetical order. The names starts with Z will come first, and then the names starts with Y next. Like reverse of alphabetical order I have to do. Okay, add. Write a program to insert string objects into the tree set. To insert string objects into the tree set. To insert string objects into the tree set. String objects into the tree set where all elements should be inserted. Where all elements should be inserted according to, where all elements should be inserted according to reverse of alphabetical order. Where all elements should be inserted according to reverse of alphabetical order. Reverse of alphabetical order. Reverse of alphabetical order. Reverse of alphabetical order. Okay, now just observe the example first, how we can do and how we can implement. Just have a look once. Here see, I'm taking TreeSet T is equal to new TreeSet of TreeSet is equal to new TreeSet. Okay, here see, T dot add of can I spell out any string names whatever there on the screen? Can you spell out? What is the first one? Oh, so brands these people, dangerous people these. T dot add of what is the next one? Shobha Rani like. Next T dot add of so Rajakumari like. So I mean, so acts as so these people, you know, for the political parties, these people acts as gods. Okay, this is, if these people are there, no one is going to comment on those political parties, because if they are going to open the mouth, then automatically very we can't. Okay, like T dot add of T dot add of Ganga Bhavani. Next T dot add of Ramulamma. So I hope some people are deprecated, I hope. SOP of T. SOP of T. Okay. Now legend this one. So here if I am not passing comparator object, then default natural sorting order. Default natural sorting order for the string objects is what the default natural sorting order for string object is alphabetical order. Can you tell what the answer now? So alphabetical order, first who is going to come? Ganga Bhavani. G starts with G. Ganga Bhavani like. And then what? And then R. But there are several string objects starts with R. First letters are same. Then second O and A same. And then M here, J here. Then automatically who is going to come first? Raja Kumari. Next one, Ramulamma. Next one, Roja. Like next one, Shobha Rani like. Okay, this is, so the output what we are going to get if I am not passing comparator object. But now my target is, sir, I don't want this output. I want reverse of alphabetical order. Can you tell what is our output, Anna? So first Shobha Rani, next what? Roja, next Ramulamma, next Rajakumari, next Ganga Bhavani. Like this is my output, what my required output, right? Reverse of alphabetical order is nothing but like what we have to do. Very, very simple. Okay. So TreeSet is equal new TreeSet of new my comparator. New my comparator. Now I am passing comparator object. Now how to implement comparator? So not required to keep much explanation. Class my comparator implements what? Comparator. Implements comparator. Class my comparator implements comparator. Now public int compare. Public int compare of object obj1 comma object obj2. Public int compare of object obj1 comma object obj2. Now I got 2. Here see which type of objects we are adding? String objects, right? So string s1 is equal to string of obj1. And legend this one, string of obj1. Anyway you are adding string objects only. Through typecasting you can convert to string. But for the string there is another facility is also there. Not required to perform typecasting. String s2 is equal to obj2 dot toString method also. Okay, toString method also. Either through typecasting or toString method you can call. Any approach is valid. But when we should go for this approach? If internal objects are only string type, then typecasting good. If internal objects may be string buffer or something like, if you want to convert to string, then toString method we can call. Anyway, now I got s1, s2. Sir, if I am not passing comparator object, then internally my JVM will call which method? Comparative method. So s1 dot comparative of s2 like it's going to call. But I want to reverse, right? If I can take return s1 dot comparative of s2. If I can take return s1 dot comparative of s2, alphabetical order will come. But I don't want alphabetical order. I want reverse of alphabetical order. Then what I have to do? Minus symbol. Like return minus s1 dot comparative of s2. Happily the code compiles and runs fine. What output by default we are going to get like this? Sir, instead of this, any alternative? Any alternative? Return s2 dot compare to of s1. That's all. If I can do, then obviously the output we are going to get our expected thing. How to insert string objects into the TreeSet? Where the sorting order is reverse of alphabetical order. Are you getting? Now just observe this one. Now 1 minute. Here I am not passing any comparator object. I am not passing any comparator object. TreeSet demo 2. TreeSet demo 2 like this. Java C TreeSet demo 2 dot Java. The code compiles fine. Java TreeSet demo 2. What the answer is? Have you observed? What the answer? First Ganga Bhavani, and then Rajakumari, Ramulamma, Roja, and then what? Shobha Rani, like we are getting. Okay. Now my target is observe. Sir, I want to pass new my comparator. I am passing new my comparator because I don't want alphabetical order. I want what? Reverse of alphabetical order. That's why next here see class my comparator implements comparator public int compare of. So either toString method or typecasting. Anything you can return. Return what? s2 dot compare to of s1. Now observe. Suddenly the output will be changed, I hope. But the answer Shobha Rani, Roja, Ramulamma, Rajakumari, Ganga Bhavani, right? Are you able to understand? Okay, this take this example, right? Take the program and output also. So this is the program to insert string objects into the tree set where the sorting order is completed, I hope. Plus my comparator implements comparator, public int compare. This is the way how to TreeSet T is equal to new TreeSet of new my comparator completed, right? Yes, and then better to take output also. Completed, I hope. Okay, take the output also. This is the output what we have to get. Shobha Rani, Roja, Ramulamma, Rajakumari, Ganga Bhavani, like. Completed, right? Shobha Rani, Roja, Ramulamma, Rajakumari, Ganga Bhavani, like. This is the output. Next one. Write a program. Next example. Write a program to insert string buffer objects into the tree set. Write a program to insert a string buffer objects into the tree set. Where where sorting order is, write a program to insert a string of buffer objects into the tree set where sorting order is where the sorting order is alphabetical order, where the sorting order is alphabetical order, sorting order is alphabetical order. Sir, here see, for string buffer default natural sorting order available or not there. So for string buffer default natural sorting is not there, but I want to insert string buffer objects into tree set according to alphabetical order. So customized sorting compulsory, right? How we can just observe here. One minute here, let me show. Okay, here just 1 minute, have a look once here. This is 1 minute. Can you please spell out here? See what objects we are adding. TreeSet is equal to new TreeSet of new my comparator. Can you tell what objects we are adding? What is the first one? T dot add of new string buffer of a new string buffer of a. T dot add of new string buffer of, what is the next one? Z. T dot add of new string buffer of, okay, k, new string buffer of k. T dot add of new string buffer of, okay, like I'm taking. Next SOP of t. Sir, here see, observe this one. What's my required output? What is the required output is a what is the next one? And then KL, which one will come first? K, next L, and then what? Z. This is our required output, right? So, but for the string buffer, natural sorting is not there. What I will do, I am passing comparator, right? Can I remove comparator object here? Ayo, can I remove comparator object? If we remove comparator object, what will happen? Immediately class cast exception, because for the string buffer default natural sorting is not there. So because string buffer objects are not comparable, that's why immediately class cast exception we are getting. Compulsory for the string buffer we should go for what? Comparator only. Now I am taking new my comparator, like I am taking. Okay, well, sir, how to implement compare logic here? Very simple. Here legend. Sir, which type of objects we are adding? String buffer objects. Okay, string buffer. Now convert the string buffer objects into string. Okay, string s1 is equal to what is the method? obj1 dot to string. In this case, compulsory to string method only. If you are trying to perform typecasting, string buffer cannot cast to string. So that's why compulsory we should go for to string method. String s2 is equal to obj2 dot to string method. Okay, simple ana. Convert string buffer objects into string, and based on this string sorting, insert the string buffer objects into the tree set. Are you getting? Just observe. Return what I have to take? S1 dot compare to of S2. S1 dot compare to of S2. Just listen. The people, you people may get confusion. Observe this one. Sir, what is the first object? New string buffer of A. Sir, new string buffer of A added ana. New string buffer of A added. Now T dot add of new string buffer object. Sir, I want to add this one. Immediately my compiler will call which method? Compare method of new string buffer of Z. New string buffer of Z will become obj1, which is already added, will become what? obj2. New string buffer of A. Correct or not? Okay. Now compare. This compare. obj1 is nothing but what? String buffer of Z. obj2 is nothing but what? String buffer of A. String buffer of A. Convert into string. If I convert string buffer and string buffer into string, S1 is what? S1 is what? String. What is the value? Z. S2 is what? A. Z A. Return. Okay. Z dot compare to of what? A. Z dot compare to of A. Z dot compare to of A means Z will come for the string. Z will come before A or after A? After A. That's why it's going to return what? Plus. Positive. Now, this positive value will come here and now. Correct or not? This positive value will come. Within this, what logic you wrote? My JVM never going to worry. What return value? What the return value I got? Positive. Now JVM is going to add this string buffer object after this string buffer. That's why. So what will happen is, now new string buffer of Z will come on right hand side. Are you able to get right? Okay, this. So convert string buffer into string, and based on string sorting, string buffer objects will be added to the TreeSet. Sir, can you tell which objects we are adding to the TreeSet? String objects or string buffer objects? String buffer objects. Based on which sorting? Based on string alphabetical order sorting. Are you getting? Based on string alphabetical order sorting, we are adding string buffer objects into the TreeSet. Sir, we are not adding string objects. We are adding which objects into the TreeSet? String buffer objects only. But how the sorting is defined? Based on string sorting, we use it, right? Are you getting? So now I have one big doubt. If we are depending on default natural sorting order, if we are depending on default natural sorting order, compulsory the objects should be homogeneous and comparable. In the morning we covered homogeneous and comparable. But if you are defining our own sorting, then the objects need not be comparable. Are you getting? String buffer objects are comparable objects or non-comparable? Non-comparable. Still, is it possible to add string buffer objects into the TreeSet or not? Yes, because we are defining our own customized sorting by using comparator. Are you getting? First take here, legend first. Here see, observe. So class my comparator, same t dot TreeSet is equal to new TreeSet of new my comparator, azkl. String s1 is equal to obj1 dot to string, string s2 is equal to obj2 dot to string, return s1 dot compare to of s2. Are you getting? Return s1 dot compare to of s2 like this. Okay, now observe this one. Sir, here can I remove this one? Hello, can I remove this one? No. Here see, what is the name? TreeSet demo 10. I removed TreeSet demo 10.java. TreeSet demo 10. Okay. Now observe. Exception in the thread main class cast exception like. Are you getting? So compulsory here we should pass what? New my comparator. New my comparator. Return s1 dot compare to of s2. What is the answer we are going to get? Have you observed here? AKLZ is nothing but like we are going to get it. Clear for all of you that? Okay, this take this example. Completed. Take the program clearly. Take clearly. Okay, completed, I hope. Next, better to take output also. Completed, right? Okay. So take the output also. What is the output we are getting? AKLZ. AKLZ, like this is the output. Okay. So take a note. Here observe. Note. Listen this one. Sir, if we are depending on default natural sorting order, compulsory object should be homogeneous and comparable. Sir, depending on default natural sorting order, but non-comparable string buffer objects I'm adding, immediately we are going to get what? Class cast exception. But if we are defining our own sorting by comparator, if we are defining our own sorting by comparator, then the objects, okay, these need not be comparable. Are you getting? Need not be comparable, need not be homogeneous also. In the next example I will explain. So heterogeneous objects also we can add, no problem at all. Okay, add. Take a note. If we are depending on default natural sorting order, if we are depending on default natural sorting order, if we are depending on default natural sorting order, compulsory the objects should be homogeneous. Compulsory objects should be homogeneous and comparable. Compulsory objects should be homogeneous and comparable. Objects should be homogeneous and comparable. Homogeneous and comparable. Otherwise we will get runtime exception. Saying class cast exception. Like, are you getting? Next para. If we are defining our own sorting, by comparator, then if we are defining our own sorting by comparator, then objects need not be comparable. Then objects need not be comparable and homogeneous. Need not be comparable and homogeneous. That is we can add heterogeneous We can add heterogeneous non-comparable objects also. We can add heterogeneous non-comparable objects also. Heterogeneous non-comparable objects also. Non-comparable objects also. That's all. Completed, right? So this is one example what we have. Next, non-comparable objects example already covered. Heterogeneous objects, how we can insert, how to define compare logic, that part I will explain. Write a program to insert, string and string buffer objects, into TreeSet. Write a program to insert string and string buffer objects into TreeSet, string and string buffer objects into TreeSet, where sorting order is, increasing length order, increasing length order. Sorting order is increasing length order. Next, if two objects having same length, if two objects having same length, then consider their alphabetical order. If two objects having the same length, then consider their alphabetical order. Okay. Now just observe the point well. Here see, one minute. Here see. Now can you spell out which objects we are adding? T dot add of a string object. T dot add of a. What is the next one? T dot add of new string buffer of what? A, B, C we are adding. Next, T dot add of new. What is the next one? String buffer of A. We are taking. T dot add of new string buffer of A. T dot add of. So what is the next one? XX. String object. T dot add of A, B, C, D. And then what? T dot add of A. Like we added. T dot add of A. Now system.out.println of T I am taking. SOP of T I am taking. Now can you tell what is our expected output? Now all objects should be inserted according to increasing length order. Sorting order is increasing length order. So can you tell first which thing will come? One length. How many one lengths are there? 2. A is there. Duplicate or not? Yes. That's why consider only one A. Next, what is the next one? 2 length. 2 length, how many are there? A is there and XX is there. Then automatically A and then what? XX. Because consider alphabetical order. If for 2 objects having the same length. What is the next one? A, B, C. 3 length. What is the next one? A, B, C, D. 4 length, right? Are you getting? A, XX, ABC, ABCD like we have. This is our required output, right? How we can do this? Very simple. Legend this one. Sir, which objects we are adding to the TreeSet? Which objects we are adding? Sometimes a string, sometimes string buffer. Let me convert both into string style. String S1 is equal to, and compare method, string S1 is equal to, what is the way? obj1 dot to string. String S1 is equal to obj1 dot to string. String S2 is equal to, string S2 is equal to, what we have to do? obj2 dot to string. Now I got string objects. but I have to arrange according to increasing length order. First find length of these things. Int L1 is equal to S1 dot length method. Int L2 is equal to S1 dot S2 dot length method. S2 dot length. Now I got length of both objects. Now if L1 less than L2, sir, here first object length is less than second object length. Lesser length object should come before or after? Lesser length object will come before or after? Before. Sir, first object length is less than second object length, then first object should come, obj1 should come before. Before means what I have to do? Return minus 1. Return minus 1. Else if so if L1 greater than L2, sir, first object length greater than second object length, then what I have to do? Return plus 1. Return plus 1. Positive. Higher length string will come next. Else can you tell what? Return if I return 0, if the two objects having the same length, consider as the duplicate. But here have you observed? AA should be there, XX should be there. If two objects having the same length, consider their alphabetical order. That's why else return S1 dot compare to of S2. S1 dot compare to of S2 means what? Alphabetical order only. Okay, end of this one, end of this. If I implement like this, then automatically all these objects will be inserted according to increasing length order. Okay, this is then the required output we are going to get, I am sure. Okay, this is now observe this one. Here see, is it the same code or not? Can you please cross check? TreeSet T is equal to new TreeSet of new my comparator. Okay, T dot add of A, T dot add of new string buffer of ABC, AA, XX same. Next string S1 is equal to obj1 dot toString, string S2 is equal to obj2 dot toString. Int L1 is equal to S1 dot length, int L2 is equal to S2 dot length. If L1 less than L2, return minus 1. L1 less than L2, return minus 1. So because small length object should come before. If L1 greater than L2, return plus 1. Higher length string should come after. That's why like else return S1 dot compare to of S2. Okay, now see TreeSet demo 12 dot java. Yes, TreeSet demo 12. Have you observed AA, XX, ABC, ABCD like that. Any explanation is required about this one? Okay, this is suppose last one. Have you observed? Else return 0 if I can take. Then what is the answer? XX won't be there because if two objects having the same length, consider as a duplicate. Now observe this. Yes, ABC, ABCD, XX gone. Okay, now what I have to take? Okay, take this example. Take clearly. Completed, right? Take clearly. TreeSet T is equal new TreeSet of new my comparator T dot yard of A T dot yard of new string buffer of ABC, new string buffer of AA, like. So here we are defining our own sorting. That's why heterogeneous objects also we can add. Heterogeneous objects also we can add. Take clearly. Okay, clear, right? So better to take output also. Completed, I hope. Yes, take the output also. Yes, what is the output we are going to get? A, XX, ABC, ABCD. So if we are defining our own sorting, then the objects need not be comparable, need not be homogeneous, right? Here in this example, which objects we are adding? Which objects we are adding? String of buffer and a string. Heterogeneous objects we are adding. Can I remove new my comparator here? No. If I remove new my comparator, how you can add heterogeneous object? Class cast exception, right? Okay, we are going to get, that's all. So now with these examples, you got the basic idea when how to implement customized sorting, how to implement default natural sorting order, like. So now my next point here is when we should go for comparable, when we should go for comparator. Okay, that part let me explain. So I have one big doubt, sir. When we should go for comparable, when we should go for comparator? Internally, JVM is always going to call comparable compared to method in the case of default natural sorting order. Okay, when, so if you want to define our own sorting, then we should go for what? Comparator. One student asked the doubt just in the break time, sir, why don't you override compare to method? What is the need of going for comparator concept? Why don't you, we can override compare to method, then automatically, so our own compare to method is going to execute, like you people may have the big doubt. Okay, make sure when we should go for comparable comparator, and is it possible to use comparable to define natural sorting order, to define our own sorting order or not? Just observe. Sir, there are three categories of classes I want to divide. All classes I want to divide into three groups. First group for predefined comparable classes. predefined comparable classes. First category, predefined comparable classes we have. Predefined comparable classes like best example for that, string concept. Correct or not? String is the predefined comparable classes, itself is nothing but string. Default natural sorting order already available. Are you getting? Because comparable compared to method is there, default natural sorting order already available. If you are not satisfied with the default natural sorting order, then we can go for what? Comparator to define our own sorting. Then you may ask, sir, why don't you override comparative method? Where we have to override comparative method? Because on the string object, JVM is going to call which method? Comparative method. If you want to change comparative method functionality, in the string class we require to change. But a string class is predefined class. We can't. Here usually not recommended to change predefined classes. Are you getting? So that's why, sir, string class compared to meant for default natural sorting order. Even we can't change its behavior because it is a predefined class, not our own class. If it is our own class, I can change. But it is a predefined Java API class, we can't change it. That's why if you are not satisfied with the default natural sorting order, then we can go for customized sorting by using which concept? Comparator concept. Are you getting? Category 1. Now, second category. Here see. Predefined non-comparable classes. Predefined non-comparable classes like string buffer. Predefined non-comparable classes like a string buffer. Default natural sorting order not there. If you want to define any sorting, compulsory we should go for what? Comparator concept only. Then immediately you may ask, sir, why don't you provide comparative method for string buffer? Sir, string buffer is predefined class. We can't perform any change in the predefined class. That's why if you want our own any sorting for the string buffer, compulsory we should go for which concept? Comparator. Okay, this is so predefined comparable, predefined non-comparable classes. Then what is the remaining classes? Okay, our own classes. Now observe our own classes like employee, student, customer, like. Are you getting? For our own classes. Who is writing this class? Ourselves only. Who is using this class? Ourselves only. Is nothing but we are writing, we are using. But make sure the person who is writing this class, the person who is using this class may not same. But both are programmer only. But the person who is writing this class, one programmer. The person who is using this class, another programmer. So same as API, some people wrote a string class, but I am using that string class. Are you getting? Some people developed string class, I am using. Being a programmer, I am using. So some X person writing our own class. Y person may use this class. Are you getting? So now observe the person who is writing this class. The person who is writing this class. Here the person who is writing this class, he is responsible to define default natural sorting order by implementing comparable interface. Because who is writing employee class? This person. Class employee implements comparable. Within that employee class, you can define what? Public into comparative method. Regarding the person who is writing employee class, he is responsible to define default natural sorting order by implementing which one? Comparable. By implementing comparable default natural sorting order, right? Next, the person who is using employee class. The person who is using employee class, he is using this class. The person who is using this class, if he is satisfied with the default natural sorting order, happily he can use directly. If he is not satisfied with the default natural sorting order, then he can define his own sorting by using which concept? Comparator concept, which is meant for what? Customized sorting, right? Customized sorting. I hope you people can very clearly read, sir. When we should go for comparable, when we should go for comparator. Comparable is nothing but predefined concept. For predefined classes, already implements comparable, we can't do anything. That's why if you are not satisfied with the default natural sorting order, we can go for customized sorting by using comparator. Same, if non-comparable predefined classes are there, then we can't change string buffer class implements comparable. That's why if you want sorting for string buffer, compulsory we should go for what? Comparator, right? But our own classes like employee, student, customer, here the person who is writing employee class, he is responsible to define default natural sorting order by implementing comparable, right? The person who is using this class, if he is not satisfied with the default natural sorting order, then he can define his own sorting by using which concept? Comparator concept, right? Are you able to understand? So this part we covered. Can you please write a program to insert string objects according to alphabetical order? Okay, default natural sorting we saw. Next, write a program to insert string objects where sorting order is reverse of alphabetical order. We covered this part also. By using comparator, how we can do that. Next, write a program to insert string buffer objects to insert all string buffer objects according to alphabetical order. We covered this concept also. Write a program to insert employee objects into the tree set where according to employee number wise or according to alphabetical order of names. This part we didn't cover. This one we have to discuss, right? Are you able to understand? When we should go for comparable, when we should go for comparator. The most valuable worthy concept, make sure you should aware. Keep subheading. Comparable versus comparator. Comparable versus comparator. Comparable versus comparator. Comparable versus comparator. Comparator. Comparable versus comparator. Okay. Yeah. First point. Better to take point by point. First one. For predefined comparable classes. For predefined comparable classes. For predefined comparable classes, default natural sorting order, predefined comparable classes, default natural sorting order already available. Predefined comparable classes, default natural sorting order already available. Already available. If we are not satisfied with that default natural sorting order, then we can define our own sorting. Then we can define our own sorting by using comparator. Okay, like next second point. For predefined non-comparable classes, within bracket like a string buffer, predefined non-comparable classes within bracket like a string buffer, default natural sorting order, not already available. We can define we can define our own sorting. We can define our own sorting. We can define our own sorting. We can define our own sorting by using comparator. We can define our own sorting by using comparator. By using comparator. Okay. Next, third one. Now here see, the person who is writing our own class, sir, our own customizer class. The person who is writing customizer class, he is responsible to define default natural sorting order by implementing comparable and comparative method. By implementing comparable interface and comparative method. What this person will do was employee class. For most of the people, what is the default natural sorting order? Based on ID or based on the name? Based on ID, because name is not unique ID. That's why what I will, this person is responsible to define natural sorting order based on ID. Like out of 100, 99% of the people satisfied with the ID sorting. The people who didn't satisfy based on ID, suppose my requirement is I want to sort all employees based on alphabetical order of their names. Then I am not satisfied with that. Then I can go for my own sorting by using what? Comparator concept. Are you getting? So for most of the times, string objects. Which type of sorting usually required for string? Alphabetical order. That's why some people define the default natural sorting order as alphabetical order only. The people who are not satisfied, out of 100, 90% of the people satisfied with alphabetical order only. The people who didn't satisfy, then they can define their own sorting by using what? Comparator concept. Same. Here the person who is writing is nothing but like, suppose if I am taking numbers. For numbers, most of the times, which type of sorting is required? Most of the times, ascending order, 1, 2, 3, 4, 5, 6 and so on is nothing but normal. That's why some people what they did is, for numbers most of the times ascending order is required. That's why some people define ascending order as default natural sorting order. Are you getting? Suppose I am not satisfied with that. Out of 100, 1 or 2 persons may not satisfy. Then we can define our own sorting by using which concept? Comparator concept. Are you able to understand that? Okay, this is same. The person who is writing employee class, he will keep for most of the people which type of sorting is required? Employee based on ID or based on employee number. That's why based on employee number define the sorting by implementing comparable. Out of 100, 90% of the people satisfied with that, then they can happily use directly. If the people who didn't satisfy sorting based on employee ID, then those people are responsible to define their own sorting by implementing what? Comparator concept. Is it clear for all of you? Okay, add. Third one. For our own classes, like employee, the person who is writing the person who is writing the class, the person who is writing the class is responsible. The person who is writing the class is responsible to define default natural sorting order, responsible to define default natural sorting order by implementing comparable interface. Responsible to implement by implementing comparable interface. Next para. The person who is using our class, the person who is using our class, the person who is using our class, comma, if he is not satisfied, if he is not satisfied with the default natural sorting order, if he is not satisfied with the default natural sorting order, then then he can define his own sorting. Then he can define his own sorting. Then he can define his own sorting by using comparator. Then he can define his own sorting by using comparator. He can define his own sorting by using comparator. By using comparator. That's all. Okay. Take these things. So predefined comparable classes like a string. Comparator concept we should go for. Predefined non-comparable classes like string buffer. Comparator concept. Our own classes like employee. Our own classes like employee. The person who is writing this class, he can responsible for default natural sorting order by implementing comparable interface. Next, the person who is using this class is responsible to implement customized sorting by using comparator. 3 categories. Predefined classes, our own classes. For our own classes, if you want, you can go for comparable. If we want, we can go for comparator. But predefined classes, we can't change. If you are not satisfied with the default natural sorting order, or if the default natural sorting order not already available, only one option, we should go for comparator. Completed, right? Which one? Recommended. Are you going to store these objects into TreeSet or not? Because the reason is, if I am not defining default natural sorting order at employee class level, then suppose 1000 people are using my employee class. Are you getting? For most of the people, 900 members commonly required what? Based on ID. Then 900 people separately they require to implement. But if I can implement at employee class level, 900 people happily they can use. They are not required to implement, right? Correct. Completed, right? So make sure you people should have clarity. The person who is writing this class, the person who is using this class, both options are there. Okay. Now, first 2 categories we covered. Let me go for this example. A bit very dangerous example. Take special care. Very dangerous example here. Just completed, right? Okay. Now listen this example well. A bit lengthy example. Take special care. Okay. Here see. Here just observe this one first. Sir, I am taking just observe basic idea. Class employee. Okay. Employee having how many properties? 2 properties. Employee name. Of course name and name and ID. What is this one? Constructor. This dot name is equal to name. This dot ID is equal to ID. Next, toString method. Sir, whenever we are trying to print employee object, internally which method will be called? toString. So how it is going to print? Something like name dot ID. Name dot ID is nothing but Durga 101. Like it's going to display, proper display purpose, right? Now here this is 2 properties are there and a constructor, toString method is there. Not required to keep any explanation up to this, right? So implements comparable compared to I will explain soon. Okay, just observe. Sir, here in the class comp like I took one class name first comp meant for what? Comparable. Second comp meant for comparator. Like anyway. Now how many objects I am taking? 5. Employee E1, E2, E3, E4, E5. So 5 objects. Have you observed? First employee name Nag 100, second employee name Balaya 200, third employee name Chiru 50, Venki 150, Nag 100. There are 2 employees with the same name, same ID. Duplicate employees are not required to insert, right? Now TreeSet T is equal to new TreeSet. T dot yard of E1, E2, E3, E4, E5, SOP of T. Forget about this second half. Sir, I am not satisfied with the default natural sorting order. That part I will discuss soon. Just observe this one. So first let me take employee class. Now listen, basic idea you got about employee. Now observe class. Now can you spell out what is the code? Class employee. Class employee. Okay, listen this one. How many properties are there, my employee? Name. Name is there. ID is there. EID or ID? EID is there. Okay, anyway. So both are, one is a string type and so on. Constructor, next a toString method already there. You can able to see on the screen. I showed, even you can take from the screen only. That's why a constructor, all those things leave. Now, sir, I'm creating 5 employee objects. 6 or 5 employee objects I'm creating. Now see this one. Employee, here see. Let me create TreeSet T or employee objects. Let me create. Employee E1 is equal to new employee of. Can you tell what is the first person name? Nag 100, first employee. Okay. Employee E2 is equal to new employee of. What is the second person name? Oi. Balaya. What is the value? 200 like. Employee E3 is equal to new employee of Chiru 50 like I'm taking. Chiru 50. Next employee E4 is equal to new employee of what is the next one? New employee of Venki. What is the value? 150. Employee E5 is equal to new employee of Nag 100. Duplicate object, I hope. Okay, now my target is, sir, I want to add these objects to my TreeSet. So that's my requirement, right? And according to employee ID wise, are getting according to employee ID wise. That's why let me create TreeSet T is equal to new TreeSet. TreeSet is equal to new TreeSet. Okay, like new TreeSet. Which objects I have to add? T dot yard of E1, T dot yard of E2, T dot yard of E3. Okay, T dot yard of E4, T dot yard of E5. Then system dot out dot println of T. I'm taking. Now do you know, is it depending on default natural sorting order or not? Yes, because I'm not passing any comparator. If I'm depending on default natural sorting order, compulsory these objects should be comparable, because internally on these objects which method will be called? Comparative method. That's why the person who is writing employee class employee implements what? Oi, class employee implements what? Comparable. Okay, listen carefully. Now which method we have to implement? Public int compare to of object obj. Like, sir, how this one will be called? T dot yard of E1. I added first object. For first object comparison is not required, but whenever we are adding second object, comparison is required or not? Yes, obj1 dot compare to of obj2. obj1 is nothing but which object we are adding, obj2 which is already there. Are you getting? Now what I have to do? Sir, within compare to method, how you can access obj2? obj2 is nothing but argument, correct or not? But where is the obj1? Where is the obj1? On which object we are calling comparative method will become what? obj1. On which object we call comparative method? How we can access that object? This current object. So current object means obj1. On which object this method called? This current object. And which object we are passing? obj2. Now it is there. Now first requirement is, sir, what is employee ID of first object? Employee ID of second object. First find out employee IDs. Int EID1 is equal to, int EID1 is equal to this. This means what, Anna? Current object. Current object means what? obj1. This dot EID. Oh, first object employee ID I got. Okay. Second object employee ID. But actually where is the second object? Here. But is coming in object form. Compulsory we have to perform typecasting. You can't ask object, what is your ID? No. You can ask employee, what is your ID? That's why typecast. What is the code? Employee is equal to employee of obj. Employee of obj. Int EID2 is equal to E dot EID. Oh, first employee ID I got, second employee ID I got. Compare these two. Compare these two IDs. If EID1 lesser than EID2. If EID1 less than EID2. Oh, first object employee ID is lesser than second object employee ID. So lesser employee ID should come first, because usually ascending order of employee IDs. So lesser employee ID number should come first. That's why obj1 should come before obj2. Correct or not? Before obj2 is nothing but return. Oh, return -1. Return -1. Else if EID1 greater than EID2. Oh boss, first person employee ID is bigger than second person employee ID. Bigger employee ID person should come last. That's why return what? Return +1. Oh, both employee IDs are same. Sir, both employee IDs are same. Oh, two employees with the same ID means equal. Equal means duplicate. Don't answer. Return 0 like. So end of comparative method, end of employee class. Are you getting? So inside employee class, by implementing comparable and comparative method, we define the natural sorting order. Can you tell which is a natural sorting order? Based on sorting based on ID. Sorting based on ID. That's why SOP of T. If I print what is the output by default we are going to get. Which employee will come first? Which employee will come first? 50 employee ID person. But in the employee class, toString method is overridden. 0 -50 first employee, because toString method called on every employee object while printing. First one. Who is the second? Nag 100. Who is the next? Venki 150. Who is the next one? Balaya 200 like. Are you able to get it? This is the output by default we are going to get. Any explanation is required? Okay, this is. So how we can implement default natural sorting order for employee class by implementing comparable interface. Clear for all of you? Okay, this is. So write employee class where sorting order is based on ID. Is nothing but like we have to write the sorting logic like. Let me consider up to this. Here see. Here observe. Class employee implements comparable string name int ID, anyway constructor, and toString method. While printing, this method will be called internally. Now public int compared to of object obj, int eid1 is equal to this dot eid. Are you getting this dot eid? Typecast int eid2 is equal to like. So first person employee ID, second person employee ID I got. If EID1 less than EID2, return -1. Else if EID1 greater than EID2, return +1. Higher employee ID person should come after. That's why 0. If else return 0, both employees are equal like. Now 5 employee objects I created, just I added 5 and I'm trying to print a T. Whatever we did on the board, same example only. Forget about remaining part anyway. Now let me execute this code. Java C comp.java. First comp completed. Comparable. Java comp. Okay. What the answer? Have you observed? Chiru 50. What the answer we got? Chiru 50, Nag 100, Venki 150, Balaya 200. Are you able to understand it? Okay, this is all employee objects inserted based on ascending order of employee IDs. Clear for all of you, right? Okay, this is. Now here observe this one. Sir, I want to insert employee objects into the TreeSet, but I am not satisfied with the default natural sorting order. My requirement is according to alphabetical order of their names. According to alphabetical order. You are not satisfied with the default natural sorting order. Then how we can define our own sorting? By using what? Comparator concept. What I will do here is see. Then if it is the case, how to create TreeSet object? TreeSet T is equal to, or T1 is equal to, new TreeSet of new my comparator. New my comparator. Oh, you are passing comparator. So your own compare method will be called. Can you tell what is the code? T1 dot of E1, T1 dot add of E2, T1 dot add of E3. Okay, T1 dot add of E4, T1 dot add of E5. Next, system dot out dot println of T1. SOP of T1. Do you know what the answer? What's my expected answer? SOP of T1 means according to alphabetical order of their names is my requirement, right? Now listen. How to implement compare logic? How to implement? Class. Can I tell what is the code? Class my comparator implements what? Comparator. Okay. What is the method we have to do? Public int compare of what? Object obj1 comma object obj2. Public int compare of object obj1 comma object obj2. Here do you know what code we have to take? Okay, here simple code. Which type of objects we are adding? Which type of objects we are adding? Employee objects. Typecast to employee form. Okay. Employee E1 is equal to employee E1 is equal to employee of obj1. Employee E1 is equal to employee of obj1. Can you tell what the second? Employee E2, employee of obj2. Okay. Next. So we have to sort based on alphabetical order of their names. Alphabetical order. That's why string S1 is equal to E1 dot name. Oh, first employee name I got. String S2 is equal to E2 dot name. S1 S2 E2 dot name. Return S1 dot compare to of S2. Because in the string class compare to method already implemented for natural alphabetical order only. That's why end of this one, end of this. If I can take like this, while adding these TreeSet, while adding these employee objects to the TreeSet, internally our compare method will be called. Our compare method is defined based on alphabetical order of their names. That's why, can you tell what is the output we are going to get? First, who is going to come? Balaya 200, comma. What next? Chiru 50. What next? Nag 100. Next, Venki 150, right? Are you able to get? So insert all employee objects based on alphabetical order of their names. Are you able to understand? Now come back to this case. Here Sir, this one I am removing the comment because second half also I want to consider. Have you observed? TreeSet T1 is equal to new TreeSet of new my comparator. Add all these objects and then SOP of T1. Okay, same. Now, how the compare logic is implemented inside comparator? Employee 1 is equal to employee of obj1. Employee 2 is equal to employee of obj2. S1, S2, both names. Return S1 dot compare to of S2. Are you getting? Now observe what is the output by default we will get. So Java C comp Java comp. Have you observed? Second answer Anna. Balaya, Chiru, Nag, Vinky. Is it sorting order based on alphabetical order of names? First one sorting order based on ID. Okay, this is. So how to use comparable, how to use comparator. Are you able to understand that? Okay, this is. So in this example, okay, default natural sorting order is based on ID. So the person who is writing employee class, he is responsible to provide default natural sorting order by implementing comparable interface and a comparative method. The person who satisfied with the default natural sorting order, happily he can get required output. The person who didn't satisfy default natural sorting order, he defined his own sorting by using what? Comparator concept. Are you able to understand? Comparator compare method. Now the corresponding output by default we got. Any explanation is required about this one? That's all. This is how to use comparable comparator for our own classes, right? Very important, most valuable concept, right? Okay, take this example. Take clearly. Okay. Completed, I hope. Take clear link. Completed, right? Clear, right? Clear, I hope. Can I complete it, right? Okay, now better to take output. So take output both. So first time sorting based on ID employee ID, but second time sorting based on alphabetical order of names. Take both outputs. Completed, right? Take the output. That's all. So this is the way how to define sorting, comparable and comparator, how to use for TreeSet sorting purpose, right? Okay, this is now let me cover a small comparison table between comparable comparator. Keep submitting. Comparison of comparable and comparator. Comparison of comparable and comparator. Comparable and comparator. Comparable and comparator. Okay, better to take a small table and comparable comparator. Do you know comparable metaphor? Comparable metaphor, default natural sorting order. First, comparator metaphor, customized sorting order. Okay, second, listen. Comparable present in which package? Java.lang package. Comparator present in Java.util package. Java.lang, Java.util. Next, comparable interface contain how many methods? How many methods? Only one method. What is that method? Compare to method. Whereas comparator define how many methods? Two methods. Which two methods? Compare method and equals method. Compare and equals method. Do you know which classes implements comparable? All wrapper classes and a string class. Have you remember? String class and all wrapper classes already implements comparable interface. But do you know which classes implements comparator? We are responsible to implement. Correct or not? We are responsible to implement. So predefined classes usually won't implement comparator. Okay, but only two classes, the only implemented classes of comparator. If you search very carefully in the total API, there are two classes which implements comparator. The only implemented classes of comparator are can you please read what is this one? Collator and rule based collator. Like, do you know, have you ever heard these words? These class names, have you ever heard about these class names? No, even I too don't know. Okay, this is not required to worry. Okay, these are things usually we can use in GUI based applications. Okay, not in our scope, not required to worry. Okay, in the GUI based application, these classes may play the role. Okay, the only implemented classes of comparator are collator and the rule based collator. That's all. Take this table. First point add. It is meant for first point. It is meant for. Now it is meant for default natural sorting order. It is meant for default natural sorting order. Default natural sorting order. Meant for default natural sorting order. Next, other side. It is meant for customized sorting order. It is meant for customized sorting order. Meant for customized sorting order. Next, second. Present in which package ana? Java.lang package. Present in Java.lang package. Present in Java.lang package. Java.lang package. Next, other side. Present in Java.util package. Present in Java.util package. Present in Java.util package. Util package. Next, the third one. It defines only one method. It defines only one method. What is that method? Only one method. Compare to. It defines only one method. Compare to. Next, other side. It defines two methods. It defines two methods. Compare. It defines two methods. Compare equals. It defines two methods. Compare equals. Compare equals. Next. String and all wrapper classes. String and all wrapper classes. Implement. String and all wrapper classes. Implement comparable interface. String and all wrapper classes implement comparable interface. Other side. The only implemented classes of only implemented classes of comparator are. The only implemented classes of comparator are collator, rule based collator, rule based collator, rule based collator. So of course these things can be used in GUI based applications, but anyway, so not in our scope, not required to worry. Just for summarize the points I added, that's all. Okay, that's all. This is about what is the difference between, or what is the comparison of comparable, comparator, right? So very important, what is the difference between comparable, comparator? Single line answer. What is that answer? Comparable meant for default natural sorting order, comparator meant for customized sorting order. Clear for all of you, right? Okay, this is next one. So up to this, how many implementation classes we covered for TreeSet, for set, hash set we covered? Have you remembered? Linked hash set we covered under TreeSet. Only 3 classes, right? Keep submitting. Comparison table of set implemented classes. Comparison table of set implemented classes. Comparison table of set implemented classes. Classes. Okay. Here see, with respect to which property we are going to compare. Okay, property. First implementation class is what? Hash set. Second one, linked hash set. Linked hash set. Third one, tree set. Oh, sorted set is an interface. TreeSet implementation classes. Okay, now here legend later you can take. Here see, the first one, what is underlying data structure? What is the underlying data structure for a hash set? Hash table. but linked hash set, linked list plus hash table, linked list plus hash table. What about tree set? Balanced tree. Oh, we covered already balanced tree. Okay. Next, legend. Later you can take underlying data structure. Next, is it duplicates are allowed or not? Duplicate objects are because all are set related classes. That's why duplicates are not allowed. Set duplicates are not allowed. No, duplicate objects are not allowed, and here also not allowed, and here also not allowed. Not allowed. Next, third one, insertion order. Sir, in hazard, preserved or not preserved? Not preserved, because it is based on hash code, not preserved. Linked hash set, preserved or not? Preserved. Linked hash set, preserved. Tree set, preserved or not preserved? Not preserved, because it talks about sorting, not preserved. Next, legend. Fourth one, what about sorting order? Can you tell a hash set ever talks about sorting? No. Sorting order, such type of concept not applicable. Linked hash set also not applicable. But what about tree set? Applicable, because it always talks about sorting only. Applicable. Okay. Next, heterogeneous objects. Do you know what about a hash set? Heterogeneous objects are allowed or not allowed? Allowed. Heterogeneous objects are allowed. Only two cases were not allowed. TreeSet and tree map. Allowed. Here also allowed. Last one, not allowed by default. But in special case it is allowed. What is that case? You know, if you define upper bound sorting by comparator, then allowed. But by default, not allowed, right? Next, null acceptance. What about a hash set? Allowed or not allowed? Allowed. But how many times? Only once. What about linked hash set? Allowed. But what about tree set? Okay, only in a particular case it is allowed. For empty tree set, the first element null is allowed. For empty tree set, as a first element, null is allowed. As first element, null is allowed. Are you able to understand that? Okay, take this table first. So property, take the table first and then I will dictate the points. Property, hash set, linked hash set, last one tree set. Hash set, linked hash set, last tree set. Hash set, linked hash set, tree set. First one, underlying data structure. Hash table. Underlying data structure, hash table. Next, a combination of linked list plus hash table. Linked list and hash table. Combination of linked list and a hash table. Linked list and a hash table. Linked list and a hash table. Hash table. Next, a tree set case. Balanced tree. Next, duplicate objects. What about a hash set? Allowed or not allowed? Duplicate objects. Not allowed. Because in every set duplicates are not allowed. Not allowed like. Next, insertion order. Not preserved. Last one, not preserved. Insertion order preserved, not preserved, preserved, not preserved. Next, what is about sorting order? For a hash set, never talks about sorting. That's why not applicable. Not applicable. Linked hash set also not applicable. Next, a tree set, applicable or not? For a tree set, applicable. Not applicable, not applicable, applicable. Next, heterogeneous objects. Heterogeneous objects. Allowed, allowed, not allowed. Allowed, allowed, not allowed. Next, null acceptance. Allowed, allowed. Allowed, allowed. Next, for empty tree set, as a first element, null is allowed. For empty tree set, as first element, null is allowed. For empty tree set as first element, null is allowed. Null is allowed. As the first element, null is allowed. That's all. Completed, I hope. Terminology is very, very clear for you people, right? Okay. For empty tree set as the first element, null is allowed. Null is allowed. That's all. Not required to keep any explanation about this one. Okay. Now, here take a note. Here there is one small twist is there. Note. Even we covered about this one. What is the word that twist? Here see. For empty tree set, yeah, the first element, null is allowed. But this rule is applicable until 1.6 version only. From 1.7 version onwards, null is not allowed even at the first element also. Okay, add note. Note. For empty tree set, for empty tree set, for empty tree set, as the first element, for empty tree set as the first element, for empty tree set as the first element, null is allowed. For empty tree set as the first element, null is allowed. Null is allowed. But this rule is applicable. But this rule is applicable until. But this rule is applicable until 1.6 version. This rule is applicable until 1.6 version only. Only 1.6 version only. From 1.7 version onwards, from 1.7 version onwards, 1.7 version onwards, null is not allowed. From 1.7 version onwards, null is not allowed. Even as the first element. 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 That's all. Clear, right? So this is about set related terminology, right? Okay. So that's all.